This is Pre-Calc 12, Chapter 6.7. We're going to look at applications of sinusoidal functions. For real-life applications, radians is not the unit for the trig functions. Typically, time is the unit for the trig functions. So you need to get comfortable with converting period to radians. And recall that b equals 2 pi radians, it's in radians, over the period. And often b will involve pi. And for some problems, sinusoidal functions will model the problems exactly. So if you're looking at waves, sound waves, light waves, and for other problems, it will produce an approximation. And let's just have a quick review. Determine a function to model the graph below. So we have a center line. And you can always do this by inspection. This center line is at 1. So d equals 1. And let's calculate the period. We can calculate the period from the center line to another center line point. So the period equals 1. So b, this is a sinusoidal function, so b is 2 pi over 3 minus 2, and that's just 2 pi. Our amplitude is max minus center line, so this is 1.5 minus 1, so that's 0.5, or better to use a half. We're moving the y-intercept straight up, so c is equal to 0. So y is equal to 1/2 sine of 2 pi t plus 1, because we're using time. When you're dealing with word problems, you need to pick out the key information to determine your A, B, C, and D. And sometimes the info will be direct, and other times it will be indirect. So let's go through some examples. The radius of a merry-go-round is 6 meters, so A equals 6 meters. The diameter of the Music Express is 10 meters. This means A is 10 over 2, which is 5 meters. Next, the bottom of the Ferris wheel is 3 meters and the top is 18 meters. So our center line, min plus max over 2, so 3 plus 18 over 2, that's 21 over 2 meters. Now we can calculate our amplitude. A is equal to 18 minus 21 over 2. So that's 36 minus 21 over 2, and that's 15 over 2 meters. So for real life examples, you're not going to get clean data, and you'll just have to make some assumptions. So this is the maximum value. And because we're skipping 29 days in between these days, we don't know if there's a higher value somewhere. Could be, might not be. This could be the maximum. And here's our minimum. Again, we don't know if it's the actual minimum because it could occur a day earlier or a day later. But we just use what we have. And we have to make a decision here. We can say January represents time equals 0. So D equals max plus min over 2. So 20.83 plus 4.34 over 2. And we have 12.585. Our amplitude is max minus center line. So 20.83 minus 12.585. And we get 8.245. And we note it takes 12 months to repeat. So b is equal to 2 pi over 12. And that's pi over 6. If we're using a sine function, we need to look at what matches the center line. And this is the closest to the center line. So our offset is 2 months. So y equals 8.245 sine of pi over 6 t minus 2 plus 12.585. Now, if we use the cosine function, it's identical except for the offset. And which month is the maximum? 1, 2, 3, 4, 5. T equals 5. Here we had t equals 2. So t minus 5 plus 12.585. One thing to note when you're figuring out the offset for sine, make sure that it starts at the center line and moves up. If you start at the center line and move down, you'll be off by 180 degrees or off by pi radians. And that is how you model a function from actual data. And that completes this lesson.